This video is a review of the concepts of scientific notation. You probably discussed scientific notation in your math class, but it might not be super fresh for you. So this is just a, hey, let's talk about the basic things you need to know about scientific notation for a chemistry class. The general format of a number written in scientific notation is that you have some number, which is often labeled A, times some amount of tens raised to the n power. So this A number has to be less than 1, excuse me, greater than 1, sorry, and less than 10. So that's A. So for instance, if I said that A was 3.35, great, that's greater than 1 and less than 10. I think I may have said the wrong thing here, so let's just go back and make sure we're real clear. So A has to be greater than 1 and less than 10. All right, there we go, nice and clear. So this is good, this works. If I chose A to be 33.5, though, that doesn't work because that's not less than 10, so this is a no-go. And if I chose A to be 0.335, that's also not okay. That wouldn't work. So I need to choose my A value so that it's greater than 1 and less than 10, or else I won't be writing the number correctly, and I would get it wrong on a test or a quiz. This n value here will be a positive number or a negative number. And where that comes from is, let's say I had 2,000, and I wanted to write it in scientific notation. What I would do is imagine that there was a decimal point right here, and think about, okay, I need to move the decimal point until I have a number that's greater than 1 and less than 10. And if I move my imaginary decimal point to right there, then I end up with an A value of 2. Now, I moved my decimal point to the left. So when we move our decimal point to the left, we started with a big number. So notice this is 2,000. It was greater than 1. And that will create a positive exponent. So I would count how many spots I moved. Here's 1, here's 2, here's 3. And that 3 becomes my value of n. So this number would be 2 point, well, we wouldn't do 2.0 in this case, so we'll just do 2, times 10 to the third. So the 3 ends up right there because I moved my decimal point that many times. On the other hand, if I have a small number, a number less than 1, like 0.095, let's say for example, I would be moving my decimal point to the right in order to create a number that is greater than 1 and less than 10. So I might move it one spot. Oh, that's not good enough. I'm at 0.95. I moved a second spot. That's 9.5. If I moved it a third spot, I would be at 95. So I know this is where I want to stop. So I see I have 9.5 here, and then I need to add in that times 10. And then I'm going to count my number of places that I moved my decimal point. Thinking ahead of myself. I moved it once here and a second time there, so my exponent is 2. Now, in this case, I moved my decimal point to the right. And because I did that, because this was a small number, I have a negative exponent. So when you move your decimal point to the right, moving your decimal point to the right, this is because you have a small number, one that's less than 1, that results in negative exponents. Okay, let's do some more practice. So let's consider the following numbers and write them in scientific notation. And first I have, looks like 30,000, and so I need to move my decimal point enough places, my imaginary decimal point, enough places so that I have an A value that's greater than 1 and less than 10. And I see that I'm going to want to poke my decimal point right there in between the 3 and the 0. Because if I stopped 1 0 before that, I'd have an A value of 30, which would be too big. And if I kept going, I would have an A value of 0.3, which would be too small. So my a value is 3. And to figure out my exponent, I'm going to count. I moved 1, 2, 3, 4 spots, and I went to the left because it's a big number. So therefore, my exponent is positive, and it's a positive 4. In the next example, we have a small number. I'm moving my decimal point to the right this time. I have 3.82 times 10, and this time, since I'm moving it to the right, it's going to be a negative number. 1, 2, 3 spots I moved it, so my exponent is negative 3. In the next example, I start with my imaginary decimal point and move it 1, 2, 3, 4, 5 spots. My a value is pretty big this time. It's 3.9208. I'm bringing every non-zero digit with me. Once we get into significant figures, we'll talk about whether we include that 0 or not. But for now, when we're just reviewing scientific notation, we are dropping zeros that are placeholders, which this is. So there's my a value. I want to say times 10 to the, and I see that I moved 1, 2, 3, let's see, I've got to do it 1, 2, 3, 4, 5 spots. And since I moved to the left, I have a positive exponent.